This is a walkthrough of GCSE Maths Practice Test Set 6. 1F, which is a non-calculator paper. The 1F means this is foundation tier, not higher tier. And question 1. Write 24,570 correct to the nearest thousand. That means I'm looking at the thousands column. I'm looking at that 4,000. I'm saying, is this number closer to 24,000 or 25,000? The 5 here tells me, the 5 following the 4 says I should round up. So that is 25,000. Part B. Write 24,570, the same number, correct to the nearest hundred. That means I'm now looking at the hundreds column and saying, should this be a 500 or a 600? The 770 tells me that I should round up. It's closer to 24,600. Question 2. The table shows part of a bus timetable from Shotton to Alton. A bus leaves Shotton at 7:30. What time should it arrive at Alton? So looking at this timetable, you might begin at the start to wonder, am I reading times forwards this way or should I be reading down? We can see that if this is when it arrives in Shotton, this is when it arrives in Alton. So if it leaves Shotton, say it arrives at the same time, 07:30, and arrives at Alton at 8:30. So we've read down the first column there. Another bus leaves Prudhoe at 8:28. 08:28. How many minutes should it get to Hexham? So the first thing to do is to find the 8:28 at Prudhoe in the timetable, which is here. And then when does it get to Hexham? At 8:45. Now this one, because they both begin with 08, it's probably easiest to do just a straightforward subtraction like that. 8:45 minus 8:28. 8 from 5 doesn't work, so we have to borrow. 8 from 15 is 7, and 2 from 3 is 1. 17 minutes. Another way you might have done that in your head, which is probably quicker, is to say if you know that 8:30 to 8:45 would be 15 minutes, and that's 2 minutes before 8:30, you've got 15 plus 2, which is 17 minutes there. Then Serena lives in Crook. She has to be in Hexham by 11:15. What is the time of the latest bus she can catch from Crook in order to arrive in Hexham by 11:15? So she needs to be in Hexham by 11:15, which we have to write as 11:15. So if we look at the Hexham row, 11:45 is too late. That's after 11:15. So she needs to get there on this bus, the 10:45 bus. What's the time of the latest bus she can catch from Crook to arrive at that time? The latest bus from Crook is this one at 10:15, which will get her there at 10:45. The next bus would get her at 11:45, which is too late. So it's this one, 10:15. Question 3. Write down the mathematical name of each of these two solid shapes. There's not much I can say about this one. You just have to recognize that the one with the circular base and the pointy tip is a cone. And if it's got the same circle top and bottom, that makes it a cylinder. Question 4. Write these numbers in order of size, starting with the smallest number. Really important to note what you're meant to start with, because lots of people make mistakes by not reading the question properly here. So starting with the smallest number, we need to look first of all at the hundreds column to get an idea. So we're putting in order in terms of the hundreds. That's got no hundreds at all there. So that's the smallest. That is the one that starts with a 1. So forget all of the other numbers at this point. Just look at the things in the hundreds column, because that's what matters. Comparing anything in the hundreds column is far more important, obviously, is far more significant a number than anything in the tens or units column. So biggest number along, we've got 98 with a 0 in the hundreds column. Then we've got a 1 in the hundreds column. Then we've got a 3 in the hundreds column. 7 in the hundreds column, and an 8 in the hundreds column. I'll just put commas between to separate them clearly. Part B, write these numbers in order of size, starting with the smallest number. So we're looking for the most negative. If that's 0, and these are positive numbers going up here, then obviously the negatives will go down here. So I'm looking for the highest digit with a minus sign in front, which is -8. Next highest digit, it does say start with the smallest again, it's -5. Then we've got -1. And then we go into the positive numbers like normal, 4, then 7. Part C, write these numbers in order of size, starting with the smallest number. So now we've got a mixture of percentages, decimals, and fractions. We need to convert them all into the same thing so that we can compare easily. Let's convert them all into decimals. So a quarter is 0.25. That's 0.2. 40% is the same as, that's 40 out of 100. 40 hundredths is the same as 4 tenths, 0.4. 3 quarters you should know is 0.75. And that stays 0.5. So looking at the smallest, again, we're looking at the tenths column and comparing the number in the tenths column. We would only bother with comparing the smaller numbers in the hundredths column if we had something the same like we do here at the smallest. We've got a 2 and another 2. This one's got nothing in the hundredths column, it's just 0.2. This one has got a 5 in the hundredths column, so it's a bit bigger, 0.25. Then going up, 0.4 is the next thing in that column. 5 is bigger than 4. 7 is bigger than 5. Some algebra. Question 5a, simplify 2x plus 2x. How many x have we got in total? 2x and 2 more x makes 4x. We just combine the number of things that we've got. 5y, take away 2y. That leaves you with 3y because 5 take away 2 is 3. 2 times 4p. If we've got 4p and times 2 is doubling it, that takes us to 8p, or 2 times 4 is 8. Okay, a probability question now. So probability always needs to be answered with a number, a fraction or a decimal, unless the question specifically says to give a word. But if it doesn't say to give a word, it does mean that it's talking about numbers specifically, fractions or decimals. So Ed spins a fair 4-sided spinner once. The spinner can land on 3 or 5 or 7 or 9. On the probability scale below, mark with a cross the probability that the spinner will land on an odd number. So odd numbers, we've got 3, 5, 7, 9. They're all odd. It's certain that it's going to land on an odd number, which is 1. Certain is represented by 1. And then part B, on the probability scale again, mark below with a cross the probability that the spinner will land on 3. Landing on 3, we can see, is only 1 out of the 4 possible options. So we've got a probability of a quarter, which is halfway between 0 and a half. It won't have to be absolutely exact, but it should be, by eye, halfway between 0 and a half. Question 7. Here is a sequence of patterns made from sticks. So we've got these 4 sticks on the base with 2 on the roof. And then we see in the second pattern, we've got the 4 sticks base with 2 on the roof. And then added to that are an extra 3 sticks for the base and an extra 2 for the roof. Pattern number 3, again, each time we're adding another 3 sticks for the base and 2 for what looks like the roof here. The number of sticks needed to make pattern 10. Work out the number of sticks needed to make pattern 10. We need to spot a pattern of what's going on here. So pattern number 1 has how many sticks? It's got 1, 2, 3, 4, 5, 6 sticks. This one has those 6 plus another 1, 2, 3, 4, 5 sticks. Pattern number 3 has the 6 plus 5 plus another 5. So there are two ways of working through this, and I'm going to look at each of them. If you're going to write it out in full, let's think pattern number 1 has got a 6 and no 5s. Pattern number 2 has got a 6 and 1 5. Pattern number 3 has got a 6 and 2 5s. So when we get to pattern number 10, it's going to be the 6 plus 9 5s. So always one less 5 than the pattern number that we're on. So we get 6 plus 45, which gives us 51 sticks in pattern number 10. Another way to do that with sequences is to write out just the number of sticks in each pattern. We've got 6, 11, 16. You could go up in 5, so you could do a list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're just going up in 5s, so we've got 6, 11, 16, etc. 21, 26, 31, 36, 41, 46, 51. And finally, a third method is to use algebraic sequences and say that this pattern that goes up in 5s is given by the formula 5n plus 1. Right, every time it's 5 lots of the pattern number plus an extra 1. So when we get to pattern 10, we'll be doing 5 times 10 plus 1, which equals 51. So any one of those methods is valid. This is the more advanced method. So if you know about algebraic sequences, that's the one that you would use. That's called linear sequences or arithmetic sequences, that method. Or nth term rule. So anyway, the answer is 51, regardless of how you get it. Okay, question 8. Here are the ticket prices for entry to a museum. Ticket prices: adult ticket £12, child ticket £7, senior ticket £8. Family ticket, 2 adult tickets and 2 child tickets, is £30. Seamus takes his family to the museum and he gets tickets for 2 adults, 3 children and 1 senior. Seamus pays the least possible amount of money for the tickets. Okay, so this is important. Least possible amount of money for the tickets. He finds the best deal, that's saying. He finds the best deal for the tickets. He pays with 3 £60 notes. How much change should he get? So there's a lot involved in this question. We're going to have to first of all find out the cheapest way of buying these tickets. And then he pays with 3 £20 notes. That's £60 that he pays with. And then we're going to have to work out change from £60. So 2 adults, 3 children, 1 senior. Either, in the most basic way, that's 2 times 12 for the adults, 3 times 7 for the children, and 1 times 8 for the senior. But we have to take account of this thing here. They didn't just put that in there by accident. A family ticket is 2 adults and 2 child tickets. So that means that we can get a family ticket for £30, and then we'll need an extra child's ticket and an extra senior ticket. So that's 30 for the family. An extra child is 7, and an extra senior is 8. And we see which one's going to be the cheapest. Presumably it's just going to be this one. So that's 37 plus 8, that's £45 using that deal. This deal, we've got 24 plus 21, so and 8. That we can see already is more than 45. That's 45 plus another 8. That's £53 in total. So that is not the cheapest. Least possible amount of money is £45. How much change should he get then from £60? We do our 60, take away 45, which leaves us with £15. If you were thinking 25, just be very careful. If you're likely to make that mistake, do the long method. Borrow from that one. 5 from 10 is 5. 4 from 5 is 1. £15. Oh, put that answer on the answer line because it's there given for us. £15. Okay, question 9. Brian is making a fence. The fence will be 4 meters long. Brian uses 4 posts, as we can see here. 1, 2, 3, 4. Each post has a width of 10 centimeters. Brian wants to have equal spaces of equal width between the posts. Work out the width of each space you must show you're working. Probably quite a few marks for this. 4 marks, yeah. Okay, so this has got units in it, and it's also got logical thinking and problem solving. So the fence will be 4 meters long, and we're dealing with centimeters though here. So let's turn the whole thing first of all into centimeters. We're going to have the fence that is 400 centimeters long. And you're thinking, presumably, of dividing that into either 4 or 3 to give the spaces. But first of all, we need to remove the width of the fence posts. So we can see that there are 4 fence posts in there, each one 10 centimeters. So the spaces are going to be what's left when we've taken away that 40. So the total of all the spaces is going to be 400 minus 40, which is 360. And we can see from the diagram that despite there being 4 posts, the spaces in between those posts are 3. So if we want to know the length of each space, we're going to have to take that 360, divide it by 3, and get 120 centimeters. Let's have a look at what unit is given on the answer. Nothing on the answer line. So we can either leave it as 120 centimeters, or you could leave it as 1.2 meters. Both of those are correct. Question 10. The diagram shows a flag drawn on a grid of squares. Grid of squares is important. Each of these is a square. Colin says that 1/4 of the flag is shaded. Colin is right. Explain why. So, the best way to do this is probably to count the squares that are shaded. Or we could do some calculations with area. But let's... I'm trying to think how to count these as whole squares. I think it's better to do a calculation with area, probably. There are lots of different ways of answering this question. It's a good idea to put some numbers in if you can. Let's say the area of the triangle is half the base times the height. And remember that's half the base times the perpendicular height. So we have to treat that as the base, this line here. And that is the height. So half times 4 times the height of 3. That's 6. Area of flag equals, we've got 1, 2, 3, 4, 5, 6 squares along and 4 squares high. 4 times 6. So we've got 24. And finally, 6 out of 24 equals 1/4. Quarter of the flag is shaded. But you could do that with different explanations. You could, for example, say that it's the full height and it goes halfway across, and therefore it's taking up 1/4 of the flag. Or you could do it by counting squares if you were going to put them together. It's quite hard counting squares on this because we don't see an immediate connection between the way these squares are being cut. So a better version is to use the numbers. That's a clearer demonstration of why Colin is right. Part B, what percentage of the flag is not shaded? So this is about reading the question carefully. If a quarter is shaded, that means that 3/4 is not shaded. You didn't need to answer question part 1 to get this right. Part A. 3/4 shaded. 3/4 is 75%. Yeah, that's just one you should know. 3/4, 75%. A way to show that otherwise would be to take it up to 3/4. How do I get to 100? To make it a percentage, I would need to, not times by, sorry, equals in there. 3/4 equals how many over 100? I would times 25 and times 25 on the numerator as well 3 times 25 is 75. That's 75%. Hopefully, you know already that 3/4 is 75%. Okay, question 11. Write down the coordinates of point A. Remember, x-axis goes first. It's always x, then y, like alphabetically, x, then y, or across, then up. So across is -2, and up is -3. Or 3 down, but we write it as -3. So coordinates of point A. On the grid, mark with across the point with coordinates 5, 2. Remember again, that's x, y. 5 across, 2 up is 5, 2 in there. And label this point B, really important to do that. Make sure you've read every line of instructions. On the grid, draw the line with the equation y equals 3. Now, if you're not sure whether that's a horizontal line or a vertical line, choose any point that has a coordinate of y equals 3. Remember, the y is the second coordinate, which is up. So that has a coordinate y equals 3. This also has a coordinate y equals 3. Doesn't matter what the x-coordinate is, y equals 3. So that is a straight line that goes through 3. That is y equals 3. Question 12. Which of these is the largest fraction? You must show clearly how you got your answer. That means that just writing down an answer, putting things in order, and not showing why is not going to get you any marks. We have 3 marks to get here. So the best way to do this is to get all the denominators the same. You've got plenty of space to work in. So I'm just going to write down each fraction. 7/10, 3/5, 29/40. How do I get all the denominators the same? Best to choose the big denominator and get them all to equal 40. So 7/10 times top and bottom by 4 to get to 40. That gives us 7 4s are 28. How do I do the same to get from 5 to 40? I would times top and bottom by 8 in that case. Three 8s are 24. So I can see that this is the smallest, this is the second smallest, and the largest one is 29/40. So, answer to the question, which of these is the largest fraction? Largest is 29/40. Okay, question 13. Here are the ingredients needed to make 12 shortcakes. And it makes it very clear this makes 12 shortcakes. It says it twice. Liz makes some shortcakes. She uses 25 milliliters of milk. How many shortcakes does Liz make? Well, we can see here that to make 12 shortcakes would be 10 milliliters of milk. So we have to think, how many times has she done this? You can either think it's everything times 2.5. Or you could think of it as double it and add another half. Either way, we're going to end up with the same number. So either I do the 12 shortcakes times by 2.5, times by 2.5. 12 times by 2.5 is 24 plus an extra 6. Right, that's 2 12s, 24. And the extra half 12 is 6. 24 plus 6 is 30. Or you might just think of that as 12 plus another 12. Double it, and then add another half. Either way, we're going to end up with the same thing. It's 30. 30 shortcakes. Robert has all of these ingredients: 500 grams of sugar, 1,000 grams of butter, 1,000 grams of flour, 500 milliliters of milk. Work out the greatest number of shortcakes that Robert can make. So here we're looking at how many times each of these is compared to the original. So how many times 50 grams is 500 grams. He can do that recipe 10 times over with the amount of sugar he's got. To get from 200 grams of butter up to 1,000 grams, he could do this original recipe 5 times over only. He's got the same with the flour. 5 times over. He's got 5 times as much flour as he needs for 12. And what about 500 milliliters of milk? 500 compared to 10. He's got enough milk to make 50 shortcakes. So the greatest number of shortcakes Robert can make, he's limited by the amount of butter and flour he has. So if he was trying to use up all his milk, he'd run out of butter and flour. So the greatest number of shortcakes that Robert can make are times by 5. This recipe, the original recipe was 12 shortcakes times by 5, which gives us 60 shortcakes. It's the greatest number he can make. Question 14. Ria is going to buy a caravan. The total cost of the caravan is £7,000 plus VAT at 20%. Ria pays a deposit of £3,000, so that's already paid. She pays the rest of the total cost in 6 equal monthly payments. Work out the amount of each monthly payment. So this is one of those long questions that's presumably worth 4 marks. Yep. So lots of processes to this. Let's find the total cost of the caravan first of all. This is a really good idea in this kind of problem to write down what you're working on as you're doing calculations. So the total of everything, we want to know the plus VAT at 20%. So 10% of 7,000 is 700, which means that 20% of 7,000 is double that, 1,400. So the total is going to be her 7,000 plus her 1,400 VAT, which is 8,400. So we get some marks for that already. £8,400. She pays a deposit of £3,000. So now we're working out her cost. So we've got her 8,400. Take away the 3,000. 3 from 8 is 5. She's got 5,400 left to pay. And she pays the rest of the total in 6 equal monthly payments. That means that we need to divide that number of 5,400 into the 6 monthly payments. So 6 goes into 5,400, 6 goes into 5 no times, 6 goes into 54 9 times, and then 0 is left over. That means that each monthly payment is going to be £900, what we get from the division there. Question 15. Buses to Acton leave a bus station every 24 minutes. Buses to Barton leave the same bus station every 20 minutes. A bus to Acton and a bus to Barton both leave the bus station at 9 a.m. When will a bus to Acton and a bus to Barton next leave the bus station at the same time? So the best thing to do here would be to write out the times when the bus is leaving to Acton. So the first one is at 9 o'clock. Every 24 minutes means the next one will be at 9:24. Adding 24 minutes to that takes us to 9:48. Adding 24 minutes to that, well, let's see, adding 20 minutes to that would take us to 10:08. So 10:08 plus another 4 is 10:12. Right, and that's an easy one. We've gone to 10. Sorry, the next one's going to be easy. Adding 24 to that is 10:36. Adding 24 to that, let's add 20:56 plus another 4 takes us to 11 o'clock. Again, you could be doing that with column method if you needed to. All of those additions. I'm going to stop there because I know that Barton leaves every 20 minutes. And that means that as I add the 20s, it's going to be 20:40 and then the hour, and 20:40 and then the hour. So I've been carrying on adding until I get to something that ends in a 0. And let's hope that it works. I know that it will work already. So we've got Acton is doing that, and Barton, the buses are doing 9 o'clock, 9:20, 9:40, 10 o'clock, 10:20, 10:40, 11 o'clock. And so actually at 11 o'clock, they should have all been like that. At 11 o'clock is the next time that they both leave at the same time. There are other ways of doing questions like that, but for something in this situation, I think that's the best way, is just to write out the times. Question 16. The table shows information about the number of grams of protein or carbohydrate and of fat in 100 grams. That's going to be important. In 100 grams of regular yogurt and in 100 grams of low-fat yogurt. Work out the number of grams of protein in 200 grams of regular yogurt. So we need to look at regular, protein, which is just reading a two-way table. 4.7. 4.7 is 100 grams of regular yogurt, and we're being asked for 200 grams, so we need to double it. 4.7 times 2. Could do it like that, I suppose. 4.7 times 2. 2 times 7 is 14. Carry the 1. 2 times 4 is 8. 9.4. Or another way to do that, just by doubling, would be to say 4.7 plus 4.7. 7 plus 7 is 4. Carry the 1. 4 plus 4 plus 1 is 9. Jane is going to compare the information in the table. Jamie, is going to compare the information in the table. On the grid, draw a suitable diagram or chart he could use. So it doesn't tell us exactly what type of chart or diagram he should use, but we're comparing things, so it's quite a good idea it seems quite a likely thing to do a dual bar chart here, and we can have a scale going up the side in grams, and then along the bottom we can have protein, carbohydrate, fat, and regular low fat. We could also do a composite bar chart where you've got the columns stacked on each other, but I think probably the easiest thing to do is to draw one. So let's look at our scale that we're trying to achieve here. We've got to go from 0 up to the highest value of 5.9. So let's make it to go up to 6 on our vertical scale. So I'm going to start at 0 here. 1, 2, 3, 4, 5, 6. I could have actually, given that I've got enough space, I could have used a full square for each one. This is fine though, as long as I'm aware that each of these little squares is 0.2 in this case. Now I need equally spaced bars, so I'm going to leave a space of 1, and then I'm going to put my first column in there for protein, and it's going to be regular followed by low fat, and then I have a column for carbohydrate, regular followed by low fat, and then for fat, regular followed by low fat. So protein, leave a gap. What was the next thing? Carbohydrate. Leave the same gap, and fat. And now I need to think about plotting these, but I also need a key, so I'm going to need to shade the columns in different ways. Maybe leave one empty and fill one in. So protein, we've got 4.7 and 5.9. So 4.7, 4.2, 4.4, 4.6, 4.7 is here. Should be using a ruler for that. I wonder if I can get that to work. Just about. It's not perfect, but it's close. 4.7 was one, and 5.9 was the other. 5.9 is right up there, halfway between 5.8 and 6. Carbohydrate, 4.7 and 5.8. 4.7 is easy enough, same as before. 5.8 instead of 5.9, so important to get that difference to make sure the graph is accurate. This is worth 5 marks. Oh no, 4 marks, this chart. And fat is 3.4 and 0.2. So 3.2.4. 0.2 is just that. And now we need to make it clear which is the regular yogurt and which is the low-fat yogurt. So I'm going to shade in all of the low-fat yogurts. and make sure that I put a key with it so that it's clear which one I'm talking about. This is just one example of many different charts that would be acceptable. So there are lots of ways of answering this question. Like I said, you could do a composite where you stack one on top of the other, or you could have put all of the regular yogurt columns together and then all of the low-fat yogurt columns together. You would need a different key that had 3 different types of shading for that one. But in this one, our key I'd put not filled in is regular, shaded, low-fat. The key is essential to make sure that we understand the diagram. Oh, and I also need to label this column grams. So always check when you finish. Oh, and the whole thing should have a title. So use the same title. Amount of fat in 100 grams of yogurt. That's what our overall title is. Not amount of fat, sorry. Amount of, what do they call it in the questions? It's amount of protein, carbohydrate, and fat, I suppose. Let's call it the in 100 grams of yogurt. Amount of, I'll just call it the whole thing. Protein, carbohydrate. Realistically, I don't think the mark scheme would penalize you for not putting a title on this one because it's straight above. But technically, all graphs should have a title, so it's always worth putting the title in. What's important in the title is the 100 grams of yogurt. Okay, next question. Question 17. Translate shape A by the vector -3, 2. Remember, with vectors, the top number refers to is it left or right. Bottom number refers to up or down. Because we've got a -3, that means 3 to the left. And the 2 is positive, that means 2 up. So every vertex, every corner of this needs to be moved the same way. 3 to the left, 1, 2, 3 to the left, and 2 up. Worth doing with a couple of the vertices, a couple of the corners, to make sure that you draw the shape in the right place in the end. So this is also going 1, 2, 3 left, and 2 up. And doing that with both corners will remind you that you're drawing it with that baseline here, rather than what we first did and then going across further left. So this is 3 and 2 up, and then that corner to that corner is 1 across, 3 up. So from this corner, 1 across, 3 up. And that one, we can see where the corners of the shape go. If you know you're likely to make mistakes with this, do it with every single corner. Go 1, 2, 1, 2, 3, and up 2. Another mistake that people make here is counting the dot itself as 1. That's not 1, that's 0, where the dot is itself. If you're moving it 3 to the left, you've got 1, 2, 3 to the left, and up 2. In this part B, describe fully the single transformation that maps shape Q onto shape R. So it's a single transformation, so don't try and combine them. Don't try to do a flip and a reflection and then a translation or anything like that. This has to be one transformation. So we can see that it's facing sideways, so it's got to have been a rotation. A rotation instruction comes with several parts. I'm going to write it at the top because it fits on my screen. It needs the instruction to rotate. And it says, is it from R to Q? No, Q onto R. We've got to be careful with that as well. Always read those really carefully. Just because R is further left doesn't mean that's the one we start with. We want to go from Q onto R. We're being asked about the transformation that takes us from there to there. So we're going to rotate Q, quarter turn, which is 90 degrees anti-clockwise. And I've already got lots of marks here. But I also need the center of rotation is the final bit that goes with a rotation instruction. This can be quite hard to find. You would use tracing paper and put it on here. Let's see if we can find the center of rotation. If I rotated it about that point, that would go from there up to there. That's no good. So what about rotating it from this point? Nope. Rotating it from... it's quite a difficult one. I think it's from the origin, in fact, which is kind of obvious, but... Okay, so let's just check that rotation. Used to be like that. You can do this by drawing an arm, like an arm bracket from what you think is the center of rotation. If I rotate that 90 degrees anti-clockwise, I have that same arm, which is 1 across there and 4 up, and it takes me to the same part of the other shape. So that's a rotation. Rotate Q 90 degrees anti-clockwise about the point, or about the origin. Or you could say center of rotation, the origin, or center of rotation, 0, 0. But this instruction here is fully correct. If you had tracing paper, of course, that does make it easier to find the center of rotation. Right, these ones are things to memorize how these works. 10 to the power of 0, anything to the power of 0 equals 1. So 10 to the power of 0 is 1. Right down to the value of 10 to the power of minus 2. The minus means 1 over 10 squared. So that's 1 over 100, which is 0.01. Write these numbers in order of size, starting with the smallest number. So this is using standard index form. Remember, the minus numbers means that we move the decimal point to the left, make the number smaller. So I'm going to first of all write all of these out as ordinary numbers. 2.73 times 10 cubed means move that decimal point 1, 2, 3 places to the right. So 1, 2 can be done. For the third, we have to put an extra 0 in. So 2, 7, 3, 0. You might also remember that 10 cubed is 1,000. So that 2 has got to be 1,000 now. 10 to the power of minus 3, we're going to move it 1, 2, 3 places. So we need 0.0273 is that one. 273 times 10 squared. Remember that 10 squared is 100. So timesing it by 10 would be adding a 0 on the end. Timesing it by 100 adds 2 zeros on the end. And then we've just got this number here, which is very small. So we're starting with the smallest. This has the most zeros in the front. So 0.00273. Next smallest is this one, 27.3 times 10 to the minus 3. Then we've got this one, 2,730, which is written as 2.73 times 10 cubed. And finally, this one is the biggest, 273 times by 10 squared. Starting with the smallest, those are all those numbers. Notice how I haven't written the versions that I wrote down here. They were just to help me. What I've written out is the numbers as they are printed in the question. Okay, another probability question, tree diagram question. Matthew puts 3 red counters and 5 blue counters in a bag. He takes at random a counter from the bag. He writes down the color of the counter and he puts the counter in the bag again. This is really important, this bit. He puts the counter in the bag again means that the bag is exactly the same in the second as it was in the first choice. He then takes at random a second counter from the bag. This is known as with replacement, because he's replacing the counter in the bag. This means that the choices are independent. You don't need to know that word to answer this question, but it's an important principle in probability. So part A, complete the probability tree diagram. We know that there are 3 red and 5 blue. So 3 out of the 8 are red and 5 out of the 8 are blue. And whenever we're doing probability tree diagrams, make sure that the branches, whatever the numbers are on the branches, they should always add to 1. So 3/8 plus 5/8 is 8/8, which is 1. And the same on the second part of the diagram as well. So each set of branches should add to 1. That's a good check to make sure you've done the right thing. Part B, work out the probability that Matthew takes 2 red counters. That would be red followed by red. There's only one way to do that from this diagram, red followed by red. And when we move along the branches, we need to multiply. So that gives me 3/8 times by 3/8. 3 times 3 is 9. 8 times 8 is 64. So probability that he takes 2 red counters is 8 out of 64. Sorry, not 8 out of 9 out of 64. Question 20. On the grid, draw the graph of x plus y equals 4 for values of x from -2 to 5. So this is a bit of a confusing one because it's not in the y equals format that we're used to. Some of you might know that x plus y equals 4 means that when x is 0, y is 4. And when y is 0, x is 4. And you therefore might be able to plot those coordinates straight away. Another way to do it would be to work out x values from -2 to 5. So this is the more standard way to look at plotting graphs. I'd say that the one that I just described is by far the quickest for this situation. So that's a better method for this situation. But if you're just using a standard method, if you're looking for x and y together make 4, if you've got -2 as an x value, you're going to have 6 in order to combine them to make 4. What goes with -1 to make 4? You would need 5. 0, 4. 1 and 3 make 4. 2 and 2 make 4. 3 and 1 make 4. 4 and 0 make 4. 5 and -1 make 4. We don't need to write down every single one of those points. Let's take the obvious ones that I mentioned first of all. And remember, this is the graph x plus y equals 4. Take those obvious ones, 0 across 4 up, 0 across 4 up, and 4 across 0 up, 4 across 0 up. We could plot any other points on that line as well. Let's take the point 2, 2, for example, is there. And then we just need to make sure we join all of those together with a straight line, starting at -2 and going down to 5 on the x-axis. So that's the graph x plus y equals 4. Question 21. The diagram shows the plan of a floor. The area of the floor is 138 meters squared. Work out the value of x. So this is a compound shape. Areas of compound shapes, we need to work out the total area. So we can see that this bit is a rectangle, probably the easiest thing to deal with, of 15 by 8. And this bit is 3 times by whatever this length is. So whatever this length is, there are different ways of labeling this. One way of labeling it would be 15 minus x. That's the best algebraic way to measure it. However, I'm going to introduce in this one or we'll just work backwards and we'll find out what that length is. So, first out, find the area of the big block, 15 times 8. Let's do that as column method. 8 5s are 40. Always put the 0 in. 8 times 1 is 80. 8 times 1 is 8. So 40 plus 80, we get 120. So that big rectangle is 120 meters squared. Let's work out the area of the small rectangle. 18 meters squared, which tells us that this length here is that 18 meters squared divided by 3. Which is 6, so that's 6 meters here. And how do we now work out what x is? Well, we know that this whole length is 15, which means that that plus that is 15. So in order to find x, we need to do 15 minus 6. This question is worth 4 marks, so even if you'd got any parts of this, you'd be getting 1 mark at a time. So we've got that length of 6. Let's do our 15, the top length, take away the 6, which leaves us with 9. So x is 9 meters. Okay, this one is definitely an algebra question. This is quite a difficult algebra question. PQRS is a square. All measurements are in centimeters. Show that the perimeter of the square is 10 centimeters. So all I've got to go on here is that these are the values they've given me. And the perimeter of the square is 10 centimeters. That means that this length is equal to this length. So we're going to be able to find out what x is by setting those two equal to each other. Remember, in the way of in maths, if you're writing an equation, equals means that they are the same. So we've got this length, 3x equals x minus 2 equals x plus 1. We've now got an equation to solve. So I'm going to get rid of the smaller number of x's on both sides. That leaves me with 2x minus 2 equals 1. Get all of the x's on one side, all of the numbers on the other side, so I need to plus 2 to both sides. That leaves me with 2x equals 3. That leaves me with x equals 3 divided by 2. I'm dividing both sides by 2 there. Which is 1.5. So if x is 1.5, and I've got sides of x plus 1 and 3x minus 2, 1.5 plus 1 is 2.5, and obviously the other side is also 2.5 because it's a square. Let's just check that. 3 times 1.5 is 4.5, take away 2 is 2.5. So all the sides are 2.5. So the perimeter is 10 centimeters. Something quite important in the way this question is written, it says show that. Show that often confuses people because it says, well, here's the answer already. How am I meant to do? What am I meant to do? Show that means answer the question as if you didn't know that was the answer and just use this value to check that you've got the right thing. So you're not meant to use this fact at all in your answer until the very end when you check that it's correct. It's basically to stop people going wrong on the way. So show that basically just means answer this question. It basically means find the perimeter of the square. This question, and then check that you get 10 centimeters. So all show that question to like that. Okay, question 23. Peter, Tarish and Ben share £54. Tarish gets 3 times as much money as Peter. Ben gets twice as much money as Tarish. How much money does Ben get? Okay, well I'm going to start with who gets the smallest amount of money. So Tarish gets 3 times as much money as Peter, and Ben gets twice as much money as Tarish. So let's just write out who gets least, who gets most. Peter gets least, Tarish in the middle, and Ben gets twice as much as Tarish. Now the reason I've done that is because I'm going to call the smallest amount of money X. And I'm going to work out everything in terms of X, this unknown amount of money. So Peter gets X amount, Tarish gets 3 times as much money as Peter, that's 3X. And Ben gets twice as much money as Tarish, so that's double that, 6X. Or you could think about this equally in terms of a ratio. They're sharing the money in the ratio 1 to 3 to 6. Either way, we now can put these together and say 6, 7, 8, 9, 10x equals 54. Or you can think about this, how many parts are there in the ratio? There are 10 parts in the ratio, 6, 7, 8, 9, 10 parts. So, and now we just go into sharing a ratio. This would be solving the equation, x equals 54 divided by 10, 5.4. We'd do the same thing here if we were working with ratios, 54 divided by 10, to share the ratio. Each share is 5.4. And now we need to look at what Ben gets. Ben is the 6 times amount. So Ben gets 6 times by 5.4. 6 times £5.40. Let's have a look. 6 times £5 is £30. 6 times 40 pence. 6 fours are 24. So that's £2.40. So total £30 plus £2.40. £32.40 is what Ben gets. Again, you could do that as a long multiplication as well. I know I'm doing lots of these questions in lots of different methods, but 6 is kind of useful to see. Times 5.4, you would do 6 times 54. Normally we put the 6 there, don't we? We do 54 times 6. And then deal with a decimal point later. 6 fours are 24. 0 in, 6 fives, 30. Add them together, and you get 324. And then you just need to think roughly what is that value to know where to put the decimal point back in. 6 times 5 is 30. It's roughly £30, so it's going to be £32.40. Make sure you put the 0 on the end, because for money, we've always got currencies, we've always got 2 digits after the decimal point. So it's not 32.4, which is confusing. It's £32.40, which is clear and easy to read. Okay, question 24, the final question. It says use ruler and compasses to construct the bisector of angle ABC. Now, angle ABC is the angle at B, always in the middle, between the line AB and the line BC. So it's this angle here. Bisector means cut in half. Now, I can't do this very well on my computer software. I'm hoping, I wonder if I can draw a circle with this software. I don't think I can, unfortunately. So I'm going to explain what I would do. I would put the compass point there, and I'd just draw an arc that goes through both parts of both lines. Doesn't have to be, I could do it in a break like that. In fact, both of these will work. It doesn't have to be any specific distance from the point, but I have the same arc that goes through both of these. Then I would move my compass point to where that arc cuts each line. So first of all, moving my compass point to here and drawing an arc inside. And then I would move my compass point here without changing the setting on my compasses. So it's got to be the same distance from there to there, and I draw the same arc from here. And as I draw that arc, it would go through there. And if I've done that accurately and carefully, then when I join that dot through the arcs, I will cut my original angle exactly in half. And that is an angle bisector. As it says here, you must show all your construction lines. That means they need to see both of those, both that arc and these 2 arcs. All 3 arcs need to be there. Even if it didn't say that, it's a general rule when you're doing constructions that you don't rub anything out. So you wouldn't rub out the arcs. What you shouldn't do here is measure it with a protractor and then cut it in half. If you do that, you won't get any marks because it's told you specifically what to use, ruler, compasses, and it's asked you to show construction lines, and it's used the word construct, all of which tells you not to use a protractor, but to do it with compasses and with arcs. Okay, that's the end of the paper. Put any comments in the chat, and I hope that was helpful. I'll be doing more of these. I'll be doing the other 2 in this set, in set 6, quite soon. Okay, that's it for now.